So we're going to talk about a special type of similarity using the triangle midsegment theorem. So the triangle midsegment theorem is saying that, so first off, these x and y represent your midpoints of the segment right here. So you're splitting this entire segment, for instance, AB, exactly in half, and then you're splitting BC exactly in half. By doing that, you are actually creating parallel lines right here. And this small triangle right here that I'm like shading in blue would be exactly half of this bigger triangle that I'm shading in red. So it's half the size. So for that reason, if it's half, based on our similarity, that means that this length xy will be half the size of AC. So like if AC were 10, xy would be 5. So it's just a special type of similarity problem. So now the other thing, like I said, is that when you split it in half, you actually get parallel lines, which is really cool, which is why they're similar, because if this is this angle and we have parallel lines, then this angle is congruent, and this one's going to be congruent to that one, and this middle angle, 2, 3, there we go, that angle B is in both of the triangles. So since all the angles are congruent in both triangles, that's why we know they're similar. So first off, you need to be able to know which sides are parallel. So if I'm doing DE, that means BC would be parallel. And then likewise, if we're now looking at DF, so that's this one right here, AC would be parallel to that one. Just put segment AC. And then we'll look at AB. So AB is this one right here. The segment that would be parallel would be EF, just that little segment right there. Now, just as a note, you can put those in different order. So I could have said CB instead, or CA, or FE. Doesn't matter the order as long as those two letters are the same. Then the next thing we got to figure out is what segments are exactly the same. Now this will seem a little weird, but DC, let's do green actually. So, or DE, sorry. DE right here is actually going to be the same length as something else. Now remember, DE is exactly half of BC, and BF is also half of BC, and so is FC. So BF is also congruent to FC, so all three of those will be congruent. So like if this were 5, that would be 5, this would also be 5. That's what we mean. Then we do the same thing with EF, so this segment right here should be the same as AD and DB, because EF is going to be exactly half of this length. So AD and DB. And then likewise, we're doing AE, so that's this one right here. Well, we already know AE is the same as EC, segment EC. And then that would also be the same length as segment DF, each one of those. Sweet. So let's figure out how you actually solve using this process. So remember, we're using, it's essentially similarity, but we already know what the scale factor is. So this 34 is going to be twice as big. So 34 is going to be twice as big as the 3x minus 1. So if I just multiply the 3x minus 1 by 2, you'll get they will be equivalent because it's twice as big. So I'll distribute, so I get 6x minus 2, then add 2 to both sides. So I'll put that over here, 36 equals 6x. I'll divide both sides by 6, so x equals 6, or 6 equals x. So same idea for this next problem. Now it does have the y's as well, but we're going to do the mid-segment first. So this is the mid-segment of this. So that means 4x minus 2 is going to be twice as big as the x plus 4. So I'll distribute. So I have 4x minus 2 equals 2x plus 8. I'll subtract 2x from both sides. So 2x minus 2 equals positive 8. I'll add 2 to both sides, and I'm running out of room, so I'll move it up here. So 2x equals 10. And then I'll divide both sides by 2. So x equals 5. Okay, so a big key for both of these, if you're doing the mid segments, notice you're going to multiply that smaller one by 2. Now, that's not what's going to happen on these others, because these right here, remember b represents the midpoint. So 4y is actually going to be the same length as this 6 times y minus 1. So I'm going to go ahead, I'm going to do it in a different color, and just say 4y equals 6 times y minus 1. So I'll distribute. So 4y equals 6y minus 6. I'll subtract 6y from both sides. So negative 2y equals negative 6. And divide by negative 2. And I'll put that over here. Y is equal to positive 3. Now, for both of these, I just noticed it also told us to find the length of AB. So in this case, AB is the 3x minus 1. So the way you find that is you plug in the x into the equation, and then you just solve. So 3 times 6 is 18. So this is 18 minus 1, or 17. So same idea right here. AB would equal x plus 4, and x is 5, so it's going to be 5 plus 4, which is 9. So there are 3 answers for that one.